Hello there, and welcome to Sleepy Cosmic Podcast, where quiet curiosity meets the night, and wonder is allowed to take its time. Tonight we open our eyes not in search of urgency or answers, but to softly drift across the long shadows of deep time. The stars above us shine with ancient patience. Their light has travelled across gulfs so vast, even the memory of its origin has quieted. And here we are, resting beneath it. Wondering, not loudly, but gently, what stories Earth might carry that we've never thought to ask. What if we're not the first? What if all we know is just a layer in something far older? If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. Wherever you are tonight, whether it's late evening or the middle of the night, I'm glad you've joined us. Now dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. We begin with a simple idea. Earth is old. Very old. About 4.5 billion years old. But even that number can lose its meaning. It's not just large, it's layered. Deep time isn't something we race through. It's something we drift across, like fog on a quiet sea. When we look at a mountain range or a weathered canyon wall, we're often peering into a timeline that stretches back hundreds of millions of years. Not just decades, not just centuries. Whole civilizations, ours included, are mere flashes in this scale. We, as modern humans, have only existed for a tiny fraction of that span. Most estimates place Homo sapiens at around 300,000 years old. Agriculture, about 10,000 years. Cities, maybe half that. And electricity, radio, digital communication, only a century or two. If the Earth's lifespan were a single calendar year, our entire history would fit within the last few minutes of December the 31st. Which brings us to the first whisper of tonight's wondering. What happened in all the other months? What lived, walked, or thought before us? We're not the first life. That much is clear. Microbial life has existed on Earth for more than 3 billion years. Complex life for about 600 million. There have been mass extinctions and recoveries. Entire branches of the evolutionary tree have risen and vanished. Dinosaurs dominated for hundreds of millions of years, and then disappeared, save for the birds that still sing in morning trees. But civilizations, thinking, building, remembering, are different. And here is where we pause to ask, very softly, if another intelligent species had risen long before us, would we know? Would any trace still remain? There's a phrase in cosmology, deep time erases loudly. It doesn't shout. It works with wind, water, heat, and pressure. Mountains crumble, oceans shift, continents drift and collide. Even the most enduring cities, stone temples, fortified walls, vanish into rubble, then into dust. What remains is often just the idea of something, a shadow in the layers beneath our feet. The mainstream fact here is simple. Earth's surface is dynamic. Tectonic activity constantly reshapes it. On average, the ocean floor is only about 200 million years old. Even continents, those great seemingly immovable masses, recycle their crust over time. It's called subduction. Plate edges dive beneath others, pulling down layers of rock, and whatever they contain, deep into the Earth's interior. But here's a lesser-known piece. Very few land areas older than 2 billion years remain at the surface today. These places, like parts of the Canadian Shield or the Pilbara Craton in Australia, are among Earth's rarest time capsules. They hold chemical traces of early life. Perhaps, just perhaps, something else too. This invites a thought, not as a claim, but a gentle speculation. Maybe civilizations are like waves. Maybe one could have risen before the dinosaurs and then faded. Astrophysicists still debate what kind of signal such a civilization would leave. Would it be in the chemistry of the soil? Strange isotopes from unusual industry? Would it show up in sediment layers, like the plastic layer our modern age is currently depositing? Or would it be gone entirely, dissolved, scattered, returned to silence? The thought is neither alarming nor conspiratorial. It's simply the nature of deep time. Earth forgets. It folds in on itself like pages in a book slowly reabsorbing their own ink. And in this forgetting, there's a kind of grace, a quiet truth about how fragile and how brief intelligence might be in the grand timeline. So as we drift onward through tonight's journey, we're not trying to uncover proof. We're not digging for aliens in the dirt or claiming secrets buried under monuments. Instead, we're allowing the question to breathe. What would it mean if we're not the first? Not the only spark in the dark? It's a question that doesn't need urgency, just stillness and time. Beneath our feet, the earth rests in layers, each one laid down quietly over years, over centuries, over eons. To walk across a field or along a rocky shore is to move across the thinest skin of this vast archive. The crust may feel solid, even permanent, but it is more like a stack of pages, pressed, twisted, folded, rewritten. We often imagine the past as just behind us, a few layers down and we might touch it. But the truth is deeper, more unhurried. The deepest parts of Earth's crust are almost entirely inaccessible. The furthest we've ever drilled is just over 12 kilometers, the Kola Super Deep borehole in Russia. That may sound impressive, but it's a pinprick. Earth's crust can be up to 70 kilometers thick beneath mountains, and it floats atop the mantle like a raft on slow-moving lava. So most of what lies beneath us we'll never see directly. Yet it's down there, holding time. Not the kind of time that runs on clocks or calendars, but geological time. Slow time. Time that reshapes the planet without rush. Some layers were once oceans, others volcanic flows. Some capture long-dead forests turned to coal, and some perhaps hold traces of things we've never imagined. Most of the time, the sediment that forms layers does so gently. Particles settle in still water, over long centuries preserving fossils, leaves, shells. But when something interrupts the ordinary, an eruption, a flood, an impact, it leaves a sudden strange signature, like a burst of ash or a thin seam of iridium from a meteorite. These become bookmarks in Earth's archive, places where the rhythm changed, and yet, for all this layering, Earth is not a careful librarian. It loses pages, rearranges them, rewrites them entirely. Plate tectonics lifts some layers up into mountains. Other regions are buried so deep, they melt and reform. This constant churn raises a quiet question. If a past civilization existed far enough back, would it leave any mark at all? We often assume that intelligence leaves behind grand traces, towers, satellites, ruins, but those require stability, time, luck. A city built on a coastal plain might vanish beneath the waves in 10,000 years. A structure made of metal might corrode within centuries. Even concrete, our modern forever material, crumbles with enough rain, salt and freeze. What's more, erosion is relentless. Wind and water wear down stone. Glaciers grind entire valleys clean. Even now, deserts swallow once lived-in places. Forests reclaim stone, rivers shift course. The deeper we go, the older the rock, but also the less specific the memory. Minerals remember heat, pressure, chemistry, but not dreams, not tools, not stories. Still, there are anomalies. Sometimes in a seam of coal or a split in ancient stone we find oddities, metal spheres, tracks, shapes that some call out-of-place artifacts. Most are natural or misunderstood, but they remind us that geology is full of surprises, and in those surprises our imagination gently stirs. We're not here to claim certainty, just to rest in the possibility that intelligence may not always leave the kind of traces we expect. Think of a civilization not built on fossil fuels, but on biology or light. Think of a culture that worked with wood and wind, whose tools were compostable, whose cities returned to the forest within decades, would we find them? Or would they vanish completely, leaving only the softest imprint, like a melody you can't quite remember? Here's a mainstream science fact that grounds us again. Most fossils we find are from creatures with hard parts, bones, shells, teeth. Soft-bodied organisms, which may have dominated entire epochs, are almost entirely absent from the record unless conditions were perfect. This is called the preservation bias, and it applies to civilizations too. What gets preserved isn't what's most important, it's what's most durable. The lesser-known detail is this. Even our greatest buildings might last only tens of thousands of years without maintenance. Radio waves fade, plastics degrade. Even in a best-case scenario, our digital cloud, the great archive of our era, might be unreadable in a few hundred years without power, without context, without the machines to decode it. Which means a future being, digging into Earth's crust 10 million years from now, might never know we were here. Or might only find a few strange hints. A narrow band in the soil, rich in rare elements, a spike in carbon, a curious shift in isotopes, as if something unusual once stirred the chemistry of the Earth. Astrobiologists often study these kinds of signals, not just here but on other planets. They call them technosignatures, chemical patterns, atmospheric anomalies, or surface features that suggest technology once touched a world. We're beginning to turn those same eyes inward. Could Earth's own deep crust hold technosignatures from a previous age? Most scientists are cautious, and rightly so. There's no strong evidence, just open questions. But the questions are gentle. They don't demand answers tonight. They just ask us to wonder, quietly, unhurriedly, what might lie beneath us still waiting to be read. The deeper we go into Earth's timeline, the more we begin to lose the threads. Not because the past wasn't rich, but because it becomes increasingly difficult to hold on to it. Consider the concept of the billion-year gap. It's not a single moment, but a recurring idea, an acknowledgement that across Earth's history there are vast spans of time where we simply don't know what happened. The rocks are there, yes, but they're quiet, worn smooth, altered, or missing altogether. One of the most mysterious of these is known as the Great Unconformity. In geology, an unconformity is a break in the record, an area where sediment layers don't match up, as if chapters of the planet's book have been torn out or overwritten. The Great Unconformity refers to a vast gap in sedimentary layers, sometimes spanning over 1 billion years, seen in many places around the world. In the Grand Canyon, for example, there's a spot where you can place your hand on ancient granite that's 1.7 billion years old, and then, directly above it, lie sandstone layers that are only 540 million years old. What happened during those missing 1.2 billion years? We don't know. The pages are missing, and that's not unusual. Throughout Earth's crust, there are countless such gaps, places where wind, water, and pressure have wiped away long stretches of story. Not maliciously, not suddenly, just slowly, with time. So we're left with questions. Not because evidence was hidden, but because it was never preserved. Because geology is an imperfect memory keeper. And here we find ourselves gently circling back to our wondering. If Earth had hosted another civilization long before us, deep before us, how likely is it that anything would remain? The answer isn't easy, but it might be, quite honestly, not very likely. Think of a wooden tool left in a forest. Within a year or two it begins to rot. Within a decade it's almost gone. 1,000 years and not a trace remains. Now stretch that to 1 million years, 10 million, 1 billion. The odds of any object surviving that long are minuscule, unless buried, frozen, or preserved in very specific conditions. Even then, most materials degrade. We may imagine a robot or a spacecraft enduring for eons, but metals corrode, plastics break down. electronics are delicate despite their power. So how do we even begin to look? This is where modern scientists turn to unusual methods. Not just fossils and ruins, but isotopic ratios, rare earth elements, atmospheric gases locked in ancient ice, things that might show indirect signs, patterns, disruptions, not proof, but whispers. A lesser-known possibility is synthetic compounds, chemicals that don't appear naturally and take a very long time to break down. Certain chlorofluorocarbons, for example, can linger in the atmosphere for tens of thousands of years. Could something like that be detected, not just from our time, but from another, millions of years ago? So far, we haven't seen anything conclusive, but the door isn't closed. It simply hasn't been fully opened yet. The mainstream view remains careful. There's no evidence of a prior civilization. But there's also this quiet truth. Absence of evidence is not always evidence of absence, especially when we're talking about billions of years. Science thrives on falsifiability, but it also allows for wonder, for thought experiments, for stretching what we know to the very edge of what might be. Perhaps in those billion-year gaps the Earth simply slept, or perhaps it dreamed something once and then let it go. And this brings us to a subtle reflection. We often think of history as linear, as progress, ever upward. But in nature, cycles are more common. Forests burn and regrow, stars collapse and reform, rivers shift and return. Perhaps civilizations too are part of this rhythm. It's a question without urgency. We're not chasing lost empires. We're listening to the deep, slow breath of time itself. And in its rhythm, we sense how brief our own moment is. Perhaps all of this has happened before, or perhaps we are the first. Both thoughts are humbling. Both invite us to care, to imagine ourselves not as owners of the earth but as guests, temporary, curious, quiet. So tonight, as we rest beneath stars that have seen the rise and fall of many things, we're not trying to prove or solve, we're simply letting the silence speak. Because sometimes, in the absence of answers, wonder becomes its own form of wisdom. Far above us the stars whisper of permanence, but here on Earth, time is more forgetful. Erosion, entropy, and motion do their work without pause, wearing down mountains and cities alike. They don't rush, they don't stop, they simply continue, grain by grain, drop by drop. It's strange to think that the very forces which allow life to flourish, water, wind, warmth, are also the agents of forgetting. They erase not just footprints, but entire histories. Take plate tectonics, for instance. This mainstream scientific process is one of Earth's defining features. The planet's surface is divided into vast plates that move over geological timescales, driven by heat from the mantle below. These motions shape continents, birth mountain ranges, and trigger earthquakes. But they also recycle the crust. Ocean floors are continually being formed at ridges and swallowed back into the mantle at trenches. Continental edges crumble and collide. In many ways, Earth is like a slow-moving washing machine, forever folding and tumbling its layers, rewriting the map. And as a result, nothing on the surface stays in place forever. A building might survive for a few thousand years. A ruin, perhaps tens of thousands. If lucky. But plate tectonics ensures that almost nothing remains untouched over millions. What does this mean for memory? It means the Earth is not a museum. It's a living, shifting body. And that presents a quiet, profound challenge to the idea of long-term legacy. Even things we consider permanent, like the Great Pyramids or Mount Rushmore, will not escape time's touch. 1,000,000 years from now, they may be unrecognizable. 10 million years, and they may be gone altogether. In this context, the idea of detecting an ancient civilization, one that existed tens or hundreds of millions of years ago, becomes less about ruins and more about residue. We'd be looking not for structures, but for signals. One lesser-known avenue of exploration involves synthetic isotopes. Some nuclear processes create elements that don't appear naturally, or appear in unusual ratios. If, for instance, a civilization had harnessed nuclear power extensively, or conducted wide-scale atomic experiments, subtle traces might remain in the soil, yet even those over time fade. Elements decay, layers mix, rain seeps downward, carrying particles deep into the earth, and tectonics again buries or melts the record. It's a kind of planetary amnesia, not because of malice or neglect, but simply because the Earth is alive. This is part of why we know so little about the earliest periods of our own planet's history. The Hadean Eon, for example, spans the first 500 million years after Earth's formation. We have almost no rocks left from that time. It's as though the planet hadn't yet learned how to keep a journal. And this brings us to entropy. Entropy is the tendency for systems to move from order to disorder. In physics, it's often associated with heat, energy, and time. But entropy also applies to memory, to structure, to civilization. Given enough time, all complex systems decay. Order requires maintenance, and when that maintenance stops, whether from collapse, abandonment, or extinction, disorder begins. Bridges fall, books rot, data degrades. Even the materials we once believed eternal, stone, gold, crystal, eventually wear down under nature's slow persistence. This is not cause for fear, it is cause for reflection. Because if we ourselves are swept away someday, not just in myth but in stone and soil, what would remain? Not our skyscrapers probably, not our cables or servers, but perhaps a faint chemical fingerprint, a thin band in the rock, a shift in the air, frozen in an ancient bubble of ice. And here, science still debates. Would such traces be distinct? Would we even know what to look for? The answer, again, is soft. Maybe. Astrophysicists studying exoplanets often use atmospheric signatures to guess at possible life. Too much methane, or a lack of equilibrium between gases, might indicate biology. But detecting intelligence, civilization, that's harder. There's no agreed-upon signature, no civilization line in the spectrum, and on Earth, the problem is the same. If a prior intelligence used tools unlike ours, or lived in harmony with nature, their traces might blend in, or dissolve completely. Some suggest that even if a civilization reached an industrial age long ago, its footprint might not be easily distinguishable after millions of years. The Earth heals, after all. It covers over wounds. It doesn't hold grudges. So we are left again, not with answers, but with openness. With the realization that time is not a vault, it is a tide. And what it carries away, it seldom returns. But there's beauty in that too, because perhaps the point is not to leave a mark forever. Perhaps the point is simply to be fully, briefly, beautifully, and then to yield, like a wave, like a forest, like a star. We too are part of the rhythm. If we truly were to vanish, what would we leave behind? This question, softly held, leads us into the quiet study of technosignatures, a term often used when searching for advanced civilizations beyond Earth, but just as relevant when turned inward. A technosignature is any detectable sign that a technology-using civilization exists, or once existed. That could be a beam of structured light, an atmospheric chemical out of balance, or even a geometric pattern on a planetary surface. Now imagine looking at Earth, not from within but from far away, from the outer edges of our solar system, or even from a nearby star. Could someone, or something, detect us? What would stand out? Our most obvious legacy might be light. For over a century, Earth has been leaking radio signals, broadcasts, telemetry, radar. They travel outward at the speed of light, forming a growing sphere of information about 200 light-years in diameter. But these signals grow weaker with distance. Within just a few light years, they dissolve into the cosmic background. Even here on Earth, we struggle to detect our own old transmissions after just a few decades of scatter and noise, and so, light fades. What about structures? A mainstream fact: most human-made structures, even the most massive ones, are vulnerable. Without continuous maintenance, cities decay surprisingly fast. Within 500 years, forests can reclaim them. In 10,000 years, corrosion and weathering reduce most buildings to rubble. In 100,000 years, almost nothing recognizable remains. Even Mount Rushmore, carved in solid granite, is estimated to erode to an unrecognizable form in about 7 million years. On a geological timescale, that's the blink of an eye. Which raises the question, if we looked for ourselves a million years from now, would we find anything at all? Scientists have proposed a few places where traces might endure longer. Caves, for example, often preserve artifacts due to their stable climate and limited exposure. Deep ocean sediments can trap and protect layers from disturbance, but even then, survival is far from guaranteed. One lesser-known idea is that of the Anthropocene layer. That's the name some geologists use to describe the current epoch of human impact, marked by plastics, concrete, aluminum, fly ash, and a sudden spike in carbon emissions. These materials, if buried quickly, could leave a thin but strange signature in the rock, a brief, chemically distinct moment in time. Future geologists, human or otherwise, might one day study this layer and wonder what we were, what we did, why we changed the air, the water, the soil. But that's assuming they notice it at all. Many layers of Earth's crust, especially those formed during rapid transitions, are thin, irregular, and easily missed. If a prior civilization had a similar technological moment, lasting only tens of thousands of years, it might leave behind a similarly subtle trace, a curious stripe, a curious silence. There's another detail. The vast majority of Earth's habitable land has been resurfaced multiple times. Floods, glaciers, volcanic flows, and shifting sediment bury and erase. Even where land has remained relatively still, it is rarely untouched. And this leads to a profound quiet in the fossil record. Between major periods of life, there are vast blank spaces. Not because life wasn't there, perhaps it was, but because the conditions for preservation weren't right. The fossil record is biased toward the lucky. What's less known is that even in the best circumstances, only a tiny fraction of all living things are fossilized. Most decay completely. Most are forgotten by the Earth. So too, perhaps, with civilizations. We think of memory as permanent, but memory is delicate. If a culture arose, flourished, and then faded, before the dinosaurs, before the trees even, it might have left only the faintest breath. A whisper between stones, a trickle in the chemistry of an ancient rock. Some speculate about strange mineral deposits, odd formations in ancient cores, sudden atmospheric changes in deep time, but nothing conclusive has been found. And so the debate continues, not loudly, but with careful thought. Astrophysicists and geologists alike wonder, would we even know what to look for? What if a past intelligence had no cities, no metals, no carbon footprint? What if they were aquatic, or lived underground? What if they communicated through fields we haven't yet learned to detect? It's not about proving anything tonight. It's about loosening our grip on assumptions, about making space for what might have been. Not to replace what we know, but to stretch our sense of what's possible. Because time is long, Earth is old, and we are new. So when we consider what we might leave behind, or what others might have left behind, we don't need to race to conclusions. We can just rest in the question. We can sit with the silence, we can listen. In the Museum of Earth's Memory, silence occupies far more space than sound. That's especially true in the fossil record. While we often think of fossils as abundant, dinosaur skeletons assembled in galleries trilobites displayed in drawers. The reality is that they are vanishingly rare. For every creature fossilized, countless others vanished without a trace. The conditions required for fossilization are specific and fragile. A creature must die in just the right place, with just the right sediment, and be undisturbed long enough for minerals to replace bone. It's not preservation, it's replacement. The original dissolves, and something stony forms in its place. And this means that most of the story is missing. Soft-bodied organisms rarely fossilize. Forest-dwelling species are almost never preserved. Entire ecosystems, wetlands, tropical canopies, even vast grasslands can come and go without leaving a page in the geological journal. So what does this mean for civilizations? Well, civilizations, like organisms, have bodies. They build, they leave waste, they move energy around, but they also depend on fragile surface-bound arrangements, roads, structures, wiring, all of it exposed to air, rain, heat, growth, erosion. And if their artifacts aren't made of stone or bone, they're even less likely to survive. We sometimes imagine that any advanced civilization would leave towering ruins behind, but even our own structures, left alone, begin to fall apart in mere decades. 100 years without maintenance and metal bridges collapse. 1,000 years and concrete becomes brittle. 10,000 and forests reclaim the landscape entirely. A lesser-known example: entire cities in Southeast Asia, once thriving, were lost under jungle for centuries. It wasn't until satellites revealed suspiciously regular shapes in the canopy that archaeologists knew where to look. If nature can so easily erase a 1,000-year-old city, what of a 1,000,000-year-old one? Or 100 million? Here we meet the quiet reality that guides much of geology and planetary science. Absence is not evidence of non-existence. And this is more than a philosophical point, it's a working principle. In the fossil record, there are entire epochs known mostly by a few scattered impressions in mudstone. In archaeology, entire cultures are reconstructed from pottery shards or charred wood. So when we look back through deep time and find nothing of intelligence, we should be careful not to confuse that with proof that nothing intelligent ever stirred. There's also a cognitive bias at play, what some call the now lens. We imagine the past as primitive because we ourselves have only recently built the technologies we know. But this is a narrow view. We assume progress always moves in a straight line, that it always begins with fire and ends with satellites. But nature doesn't follow lines. It loops, branches, resets. Forests burn and regrow. Rivers dry and return. Species flourish and vanish, only for something similar to arise again later. So perhaps intelligence too is cyclical. Perhaps it rises, briefly burns bright, and then yields again to the slow, quiet rhythm of biology. If that's true, the fossil record might miss it almost entirely. We've already found ancient skeletons that defy easy classification, strange hominids in caves, tiny humanoids on islands, jawbones with odd features. They may not be civilizations, but they remind us that even within our own lineage, the story is complex, branching, and largely lost. There is also the matter of tools. Mainstream archaeological dating often relies on artifacts, stone tools, metalwork, ceramics. But what if a civilization didn't use those? What if their tools were ephemeral, made of materials designed to dissolve or recycle? We might imagine a people who lived lightly, whose settlements vanished with the seasons, a culture that worked with sound, with magnetism, with invisible fields. Would we ever detect them? Or would their entire history pass beneath our feet like a forgotten breeze? Some researchers point to the archaeological principle known as signal to noise. In heavily disturbed layers, small anomalies are easy to miss, like whispers in a windstorm. And in Earth's crust, most layers are disturbed, uplifted, cracked, tilted, overwritten. The signal is always faint. So even if a single artifact, say, a metal rod from a forgotten machine, were to survive, would we recognize it for what it was? Or would we dismiss it as a curiosity, a mineral oddity, a mistake? There's humility in that thought. Not fear, not paranoia, just humility. Because we like to believe that our achievements are permanent, that the cities we build will last. But permanence, it seems, is an illusion. The mountains fade, the seas move, even stars eventually fall silent. So we're left not with evidence but with a question. If civilizations can vanish without a trace, how would we ever know they existed at all? And more gently still, if we too fade, will we be remembered? Or will we, like so many before us, if there were any, become part of the long silence that follows? In myth and legend, there is a place that rises again and again, a city lost to time, swallowed by the sea, Atlantis. Plato's tale of Atlantis is likely allegory, a philosophical thought experiment wrapped in the shape of memory. Yet the story has endured for millennia. Why? Perhaps because it speaks to something deep and quiet within us. The fear that what we build can vanish, and the wonder that maybe, just maybe, it already has. We aren't here to revive Atlantis in the usual sense. No sensational claims, no secret maps or sunken temples. But there is something to be said for approaching the myth not as a destination, but as a question. What would it mean if an entire civilization had once thrived, then disappeared so completely that it slipped from the geological record? It's not so impossible. Let's drift gently through the lens of possibility. Coastal regions are vulnerable. Over 10,000 years ago, as the last ice age ended, sea levels rose by over 100 meters. Entire stretches of land, once populated with mammoths, forests and early humans, were slowly swallowed by the rising tide. Places like Doggerland, a land bridge between Britain and Europe, disappeared beneath the North Sea. We only discovered it through sonar and chance dredges of ancient tools from fishing boats. Now imagine if a complex society had lived there. Not one like ours, but one quieter, less sprawling. Would we even know? That's the humbling idea behind many modern reconstructions. Civilizations don't need skyscrapers to be advanced. They don't need electricity or cities to change their world. Some researchers speculate that if a maritime culture had evolved tens of thousands, or even millions of years ago, and clustered along the coasts, rising seas could erase most physical traces. Wave by wave, sediment by sediment, memory would fade. The mainstream understanding of sea level rise helps us here. It's not a sudden flood. It's a slow encroachment. Over centuries, coastlines shift, deltas submerge, and with them, anything left behind. This is part of why so much ancient history remains underwater. Many early human settlements, especially in the Mesolithic period, are now submerged. Archaeologists exploring these regions find fire pits, tools, even wooden walkways preserved beneath the silt. But they're rare, fragile, and difficult to access. That's a lesser-known challenge. Underwater archaeology is still in its infancy. Vast regions of seafloor have never been explored in detail. The oceans cover over 70% of Earth's surface, and we know less about their depth than we do about the moon. Could the sea be keeping secrets? Not conspiracies, just forgotten things. A ring of stones, a shaped basin, a pattern that no current explains. None of this is proof, but it opens the door to possibility. Even now, we find things we don't fully understand. Stone structures beneath the waters near Japan, large geometric patterns off the coast of India. Are they natural, man-made, misinterpreted? We don't know. And that's all right, because the real value isn't in solving the mystery. It's in remembering how fragile memory is. Atlantis, then, becomes a metaphor. Not just for a lost city, but for the idea that entire ways of being can disappear. Not with a bang, but with a sigh. Not because they failed, but because time is long and the earth forgets. In that forgetting, there is no cruelty, only movement. Tides rise, rivers shift, mountains wear down to hills, and so we are reminded that permanence is not nature's way. When we hear of a city swallowed by the sea, or a culture buried beneath ash, it's easy to imagine disaster. But sometimes forgetting happens gently, like dusk settling into night. There may never have been an Atlantis, but there have been places and people and moments now lost that were once as vivid as our own. Perhaps civilizations rise like waves, each one curling upward, catching the light, and then falling back into the sea of time, and perhaps, every so often, a new one rises, unaware of the last. That doesn't make us insignificant. It makes us part of something ancient, a rhythm, a pattern too vast to see from within. So we drift onward, not looking for Atlantis, but listening for its echo, a ripple, a hush, a whisper just beneath the surface. From far above, deserts appear still, vast seas of sand under an unblinking sky. Their silence is not empty, it is patient, and in that patience they may keep secrets. Unlike jungles or oceans, deserts preserve. They are dry, stable, and largely undisturbed by weather or life. Where rain and roots might break down a structure in a forest, the desert often entombs. Footprints can last for centuries. Tools, bones, even textiles have survived thousands of years beneath the dunes. This makes deserts ideal candidates when we begin to wonder gently about what the Earth might still be hiding. Consider the Sahara. Today, it stretches nearly 10 million square kilometres, but it wasn't always this way. Roughly 6,000 to 8,000 years ago, during what's called the African Humid Period, much of the Sahara was green. Lakes shimmered under the sun, rivers flowed, crocodiles and hippos swam where now only dust swirls. Humans lived there too, carving stones and painting the walls of rocky shelters with giraffes, dancers and boats. We know this not through ancient texts, but through aerial surveys, satellite imagery, and the discovery of lost rivers buried beneath sand. One lesser-known fact: satellite data has revealed what may be traces of large, ancient lakes and even possible settlement patterns beneath the Sahara's surface. Not proof of cities, just gentle clues, shapes too regular to be chance, lines that don't match natural wind patterns, a suggestion, nothing more. The deeper we look, both in data and in time, the more the desert transforms from a void into a veil. There is something deeply poetic in that. A desert, by its nature, resists permanence, but in its refusal to change, it preserves. Objects found in Egypt's dry tombs have lasted thousands of years. Wooden boats, scrolls, cloth, ink. Elsewhere, mummified remains of people and animals have been found naturally preserved by arid winds and salt-crusted soil. So we must ask quietly, if another civilization once lived in a time now lost to deep prehistory, before the ice ages, or perhaps between them, might a desert somewhere still hold its breath? Modern technology is only beginning to help us look. LiDAR, which bounces lasers off the ground to map hidden features, has revolutionized our understanding of jungles. But deserts too are being scanned, and what we find sometimes are oddities, straight lines, rectangles, shadows that look less like dunes, more like walls or foundations. Again, not proof, just hints. It's easy to get carried away. The mind wants patterns, it wants stories. But the science remains careful. Many of these formations are likely natural, geological quirks. Others perhaps are more recent than we assume. Still, the possibility lingers, not loudly, just calmly. Could there be places we've overlooked? Deserts not evenly explored? Much of the central Sahara remains largely unmapped at high resolution. The same is true for parts of Arabia, Central Asia, the Australian outback. These are areas where preservation is most likely, where the sands do not churn as oceans do, where tectonics move more slowly, where a structure buried might sleep undisturbed for millennia. There's also the issue of our attention. We often look for what we expect: stone walls, metal tools, recognizable forms. But what if we should be looking for something else? An unusual mineral concentration, a buried pattern of magnetic anomalies, a strange symmetry in a sea of chaos. This is how science sometimes begins, with a question that won't quite go away. Astrobiologists face a similar problem when scanning distant planets. They don't look for cities, they look for irregularities, things that don't belong. Things that nature doesn't usually make on its own. We can use the same lens on Earth, not to prove, not to claim, just to ask. Could deserts, in their hush and stillness, be holding pieces of a forgotten story? A curved stone here, a layered artifact there, something that doesn't match the rest. It wouldn't have to be grand. Even a single object in the right context could shift our sense of time. But even if we never find one, there's value in the wandering. Because deserts teach us something subtle, that erasure is not always loud, that memory sometimes hides not in noise, but in silence, and that in the still places, the lost things wait longest. So we gaze over the sand the same way we gaze at the stars, not to conquer, not to prove, but to listen, just in case something ancient is whispering back. High above us, in a sky that never changes, floats something that never forgets: the moon. For all of Earth's motion, its oceans, its weather, its restless crust, the moon is different. It is silent, it is still, and in its stillness it holds time. Unlike Earth, the moon has no atmosphere to stir wind, no running water to carve valleys, no tectonic plates to shift continents. Its surface remains as it was, battered, yes, but preserved. Some of the footprints left by Apollo astronauts more than 50 years ago are still there today, untouched. A human step in lunar dust, outlasting empires. Now imagine what else might linger. This is not speculation, but fact. The moon is an ideal place to store a memory. Not because we meant it that way, but because it doesn't erase. That idea has begun to take root among scientists and futurists alike. If we wished to preserve a message for 1 billion years, they say, we wouldn't hide it in a cave or bury it in a vault on Earth. We would place it on the moon. Some already have. The Apollo missions left behind not only footprints, but instruments, flags, even plaques. Later, the Lunar Reconnaissance Orbiter photographed these sites and confirmed they're still there, unchanged. It's a reminder that, in the great cosmic archive, the moon might be one of the safest shelves. And that raises a gentle, curious thought. If we've used the moon as a kind of time capsule, could someone else have done the same? It's not a popular theory, but it's not impossible either. Mainstream science confirms that the moon is old, roughly 4.5 billion years, about the same age as Earth. Its surface, though, is much older because nothing clears it. Some of the craters we see from our backyards are more than 3 billion years old. This makes the moon a unique geological record. If any object, artificial or otherwise, landed on it in deep time, it might still be there. A lesser-known fact: scientists working with SETI, the Search for Extraterrestrial Intelligence, have proposed examining the moon's surface for anomalies, not just from our activity, but from any possible visitor. They call this Lunar SETI. The idea is simple, even elegant. If advanced life passed through this solar system, the moon would be the obvious place to stop. It requires no fuel to land, no permission. It offers a perfect view of Earth, and anything left behind could stay intact for millions, even billions of years. Again, there is no direct evidence of such a visit. No structures, no artifacts. But we've only mapped a small portion of the moon's surface in high resolution. Much remains unexplored. There's also the idea of buried traces. Micrometeorite impacts gradually cover and shift the lunar soil, what scientists call regolith. This could preserve or even hide older objects beneath a shallow dust layer, and here the moon's silence becomes profound, because unlike Earth, it remembers. It remembers impacts. It remembers radiation. It remembers the quiet arrival of each machine we've sent, and perhaps, if something came before us, if anything touched this solar system long ago, it would have left a fingerprint here, not a city. Not a monument, but maybe a shard, a shape, something that doesn't belong. Even if we find nothing, the idea changes us. It reframes our relationship with space. It reminds us that we're not only explorers, we're also being recorded. Every satellite, every rover, every trail of dust kicked up by a landing leg, the moon watches, and it keeps what we forget. We may even find our own messages one day, records we leave now, rediscovered by future humans in ages so distant we can barely imagine them, or by something else. Because the moon is not just a rock, it is a mirror holding light. It is a library holding silence. And when we think of lost civilizations, not just on Earth but beyond, it is the moon that becomes the witness, always turning toward us, always the same face, a pale guardian of memory waiting in the velvet dark. So if ever there was a place where the past might have left something behind, and where time would not steal it away, it is here, right above us, always watching, always remembering. Now we drift outward, just a little farther, past the moon's gentle orbit and into the quiet red dust of a world that once had water. Mars. Mars has always felt strangely familiar, not because it's like Earth, but because it's like a memory of Earth. Dry rivers, empty basins, traces of something that used to be. And that's where our curiosity stirs again, just a bit. Mainstream planetary science confirms this. Mars once had lakes, rivers, even oceans. Billions of years ago, the red planet may have been blue. Its atmosphere was thicker, its climate warmer. There were clouds, storms, rainfall. And where there is water, especially over time, there is always the potential for life. We've sent many machines to look. Orbiters, landers, rovers. They've found pebbles worn smooth by flowing water, minerals that form only in wet conditions, and sediment layers, quiet, undisturbed, suggesting ancient lakes that lasted long enough to cradle life. What we haven't found yet is evidence of that life. But the search is just beginning. What's lesser known is that scientists aren't just looking for microbial life. Some are now willing to ask the quieter question. If life had a long time to evolve on Mars, could something more have emerged? Not cities, not radio towers, but intelligence, tool use, culture. Maybe not like us, but not entirely unlike either. If such a species ever existed, it likely vanished long ago. Mars has been dry for at least 2 billion years. Its magnetic field collapsed. Its atmosphere leaked away. Its surface was blasted by radiation and bombarded with meteorites. It became, in essence, a tomb. But tombs can preserve, and Mars, especially its deep craters and shadowed valleys, might hold on to traces. We're only now learning how to look. NASA's Perseverance rover, exploring Jezero crater, is tasked with collecting samples that might one day be returned to Earth. Those samples will be the first ever retrieved from another planet, and inside them may lie ancient organics, or at least the chemistry of life. But what if the most interesting clues lie not in biology, but in anomalies? There are features on Mars that spark gentle debate, strange geometric mounds, shadows that look just a little too regular, patterns that seem carved, then fade under closer inspection. Most are illusions, tricks of light, erosion, pixelation, but not all. There's a lesser-known proposal in planetary science called the Silurian hypothesis. It suggests that if a technological species had once existed, not on Mars but even here on Earth, Millions of years ago, its traces might be indistinguishable from natural patterns. The idea isn't meant to suggest ancient aliens or hidden truths. It's meant to explore how hard it is to find evidence of a short-lived civilization in deep time. The same logic applies to Mars. If something intelligent once emerged and was then lost, what would we expect to find? Not bones, perhaps, not tools, but maybe anomalies in the soil, unusual isotope ratios, structures of synthetic material embedded in ancient rock. Even the suggestion of regular geometry, circles, right angles, would invite closer study, but we must be careful, because Mars, like Earth, shapes things on its own. Wind can sculpt symmetry, ice can crack stone with precision, lava flows can harden into patterns that look familiar. So our task is not to jump to conclusions, but to remain open. Because Mars holds another secret, it may not be done. Beneath its surface, shielded from radiation and extremes, there may still be warm pockets, water, even microbial life. And if life is still there, quiet, surviving in the dark, what else might it remember? We tend to think of intelligence as something unique, singular, rare. But maybe it's more like a rhythm, an echo that re-emerges whenever the conditions are right. Mars had those conditions. Once. And if it happened before, there or here, it could happen again. So as we study its valleys, its deltas, its buried lakes, we're not just searching for microbes, we're searching for a sense of continuity, for the possibility that we are not the first to wonder, not the first to look at the stars, not the first to leave a mark, not the first to vanish. Mars may never yield that answer. Or it may be holding it in one quiet layer of sediment, waiting. Either way, the silence speaks, and we listen. Now we turn to a world wrapped in clouds, Venus. It hangs in our sky like a pale, beckoning star, brightest before sunrise or just after sunset. But beneath that glow is a planet of extremes. Mainstream planetary science gives us the basics. Venus is roughly the same size as Earth. It likely formed from the same dust cloud. It has mountains, valleys, volcanoes. But the surface temperature is hot enough to melt lead. Its atmosphere is thick with carbon dioxide, cloaked in sulfuric acid clouds and crushingly dense. To most it seems lifeless, inhospitable, a furnace. But it wasn't always that way. One of the more remarkable shifts in recent decades has been the scientific re-evaluation of Venus's past. Many researchers now believe that Venus may once have been temperate, that for hundreds of millions, perhaps even billions of years, it had shallow oceans, moderate temperatures, and perhaps the chemistry necessary for life. It is even possible that Venus was habitable longer than Mars. This idea rests on climate models, the ratio of certain isotopes in its atmosphere, and comparisons to Earth's early evolution. But Venus changed. Something happened. Its oceans, if they existed, boiled away. The greenhouse effect ran away from itself. Now the planet is locked in a kind of catastrophic equilibrium. But here's the gentle, lesser-known question. If Venus was once habitable, was it ever inhabited? And if so, did that life remain microbial? Or, over time, did something more complex arise? We don't know. The surface of Venus is extraordinarily hard to study. Only a few landers have survived long enough to send back images. Most failed within minutes. The Soviet Venera missions in the 1970s and 80s were the most successful, capturing brief glimpses of cracked stone and sulphurous skies. But no rover has ever driven there. No drone has ever flown above its valleys. What we know comes mostly from radar and orbiters, looking down through clouds that obscure nearly everything. One peculiar thing stands out. Venus's surface appears relatively young, geologically speaking. Most of it seems to have been resurfaced around 500 million years ago. Why? Scientists don't fully agree. Some propose massive volcanic activity. Others suggest a global crustal overturn, where the planet's entire outer shell melted and re-solidified. But whatever the cause, that resurfacing would have erased nearly all previous geological history, a clean slate or a quiet forgetting. So again, we're faced with a question not of evidence but of possibility. Could Venus have once hosted a civilization, not one like ours, not necessarily radio transmitting or spacefaring, but one adapted to its own world, perhaps living in oceans that no longer exist, under skies that once held rain instead of acid? It's speculative, yes, but not unscientific. Astrobiologists consider Venus a paradox. It's similar to Earth in so many ways, yet it evolved so differently, and that divergence may hold clues, not just to what could be on other worlds, but to what was and what might have been lost. A few missions on the horizon aim to study Venus in more detail. NASA's Veritas and Da Vinci Plus and ESA's Envision may give us better maps, better data, even a glimpse of the deeper crust. They might help us understand how a world that could have been Earth's twin became its burning mirror. Because that's what Venus is, a reminder, a warning, a mystery. If civilizations are fragile, if they depend on a balance of temperature, pressure, chemistry, then Venus is a cautionary tale, not just in the way of climate, but in the way of memory. Because if something once lived there, it's gone, and the signs are buried under lava, acid, and heat. Still, we wonder. Perhaps traces remain in the upper clouds, where temperatures are milder. Some scientists have even proposed that life, simple, microbial, could survive there, floating in droplets. Unlikely, but not impossible. And if life persists, even now, what stories might it carry? What memories might it keep? We may never know. But in drifting across Venus, we remember that loss is part of the cosmic rhythm, that not all stories are preserved, and not all worlds remain what they once were. Some become echoes, some warnings, some still unopened books, and some, like Venus, shine quietly in the twilight, waiting. As we drift farther out, beyond Earth, beyond the Moon, beyond Mars and Venus, our gaze begins to widen. We stop looking only down, into the soil of familiar planets, and begin looking outward, toward the stars, toward the dark between them, toward the quiet that stretches in all directions. And we ask a question we've asked before, softly this time. Are we alone? It's the question behind so much of modern astronomy, behind telescopes and satellites, behind radio dishes and exoplanet surveys. But tonight we're not asking it in the usual way. We're not wondering whether other civilizations currently exist. We're wondering whether, somewhere out there, we already were them. This is a reversal, a gentle flipping of the usual narrative, because we often imagine the universe as a grand stage on which we have just arrived. The newcomers, the curious, the only ones with light in our windows. But what if we are not the first, not even here on Earth, and also not the only? What if civilizations come and go, not just on single planets, but across star systems? It's a possibility more scientists are beginning to hold space for, even if quietly, not because there is evidence of other intelligences, but because of the Fermi paradox, the eerie silence. The Fermi paradox asks, simply, if intelligent life is common, where is everyone? With billions of stars in our galaxy and billions of galaxies beyond, the math suggests we shouldn't be alone, and yet we hear nothing. No signals, no beacons, no artifacts drifting through the void. This silence is one of the great mysteries of modern science, but tonight we let it speak back to our earlier wondering. Because perhaps the silence is not because no one else ever existed. Perhaps it's because most civilizations don't last long enough to cross the stars. Or perhaps they do, but not in ways we recognize. A lesser-known possibility within this debate is the concept of temporal dispersion. It suggests that even if intelligent life is common, civilizations may emerge at vastly different times. Imagine A species flourishes, sends out signals for a few thousand years, and then fades. Millions of years pass. Another arises. Its messages, too, are short-lived. Unless two civilizations arise at the same time, and within signal range, they may simply miss each other. We call this the cosmic window. And ours may only just be opening. If others opened before, briefly, long ago, then their light has already passed us by. It's like watching a lighthouse blink once, then vanish behind fog, and if we extend this line of thought even further, we reach something even more humbling. What if Earth itself has already participated in this cycle more than once? What if an intelligence rose here long ago, millions or even hundreds of millions of years back, left traces, sent signals, and then vanished? And what if its messages are now lost, scattered in cosmic dust, drowned in the background noise of time? It's not science fiction, it's a thought experiment that rests gently on the boundaries of current knowledge. Because while we search the stars for signs of others, we rarely ask whether we might already have sent signs long ago, from a version of ourselves we no longer remember. In this view, Earth becomes not just a cradle, but a stage that has seen more than one act, and we are simply the latest players to step into the light. If that's true, it changes how we look outward, no longer searching for others as strangers, but perhaps as echoes, not alien but familiar, not foreign but ancestral. Perhaps the signals we seek aren't ahead of us, but behind, lost in time, lost in memory, or perhaps waiting quietly to be heard again. The silence of the universe isn't loud, it doesn't shout, but in its quiet it invites us to listen more deeply, to look, not just with telescopes, but with humility, not just with hope, but with perspective. Because in that vastness there is room for many stories, some still unfolding, some long gone, some maybe even ours, once before. If the stars are silent, perhaps it is because the echoes we seek are buried, not in space, but in time. This brings us to a quiet turning point in our wondering. What if the Fermi paradox isn't a question about others, but a reflection of ourselves? We often frame it as a search. Where are they? But maybe the silence we hear is the same silence the cosmos once heard from us, long ago. And if Earth has indeed hosted intelligent life before, whether us or something else, then perhaps this silence is not an absence but a pattern. Civilizations may not always expand, they may not always broadcast, they may not last. Or they may not want to be seen. There is a concept, softly speculative, called the dark forest hypothesis. It imagines the universe as a forest at night. Each civilization is like a creature hiding among the trees, knowing that any noise might attract attention, good or bad, so they stay quiet. This hypothesis is dramatic, but we don't have to take it literally. Instead, we might borrow its mood, that perhaps civilizations, by nature or by experience, often fade into quiet. Or perhaps they become something else entirely. A lesser-known idea in the world of astrobiology is that of post-biological evolution. In this view, the intelligence may eventually shed its biological form, transforming into something digital, quantum, or otherwise beyond our understanding. If such civilizations exist, they might not use light or sound as we do. They might not build towers or travel in rockets. They might dwell in forms of matter or computation we've never imagined. And if so, would we even recognize them? It's possible that the signs of intelligence are all around us, hidden not by distance, but by unfamiliarity. Patterns in gravitational waves, subtle anomalies in dark matter, fluctuations in the structure of space-time itself, or, more softly still, perhaps those signs passed through long ago, and we missed them, not through failure, but through timing. This is what some call the brief signal hypothesis. Civilizations may leave behind only a flicker, short-lived messages, subtle traces. Unless another intelligence is listening at exactly the right moment, the message fades into cosmic background. That's a sobering thought, because if this is true, it may apply to us as well. We too may only be broadcasting for a short while. Our radio age is barely a century old. Already, many of our signals are being replaced by cable, fiber optics, encryption. To an outside observer, Earth may grow quiet again within another 100 years, and so our own signal might become a whisper, a faint ripple across the stars, one more light blinking once in the forest, and then going dark. Does that mean we're doomed? Not at all. But it reminds us of the scale we're working within. Galaxies rotate over billions of years. Stars live and die in slow rhythms. Civilizations, if they come and go, may be like sparks on the surface of the sea, bright for a moment then lost to the waves. So when we ask, why is no one out there? Perhaps we should also ask, how long do sparks last? And maybe more gently, how many sparks have already come and gone? Earth may be one such spark, or perhaps one of many on this very planet. Because when we think about civilizations, we often focus on scale, how big, how advanced, how far. But time is just as important. If a civilization rises, leaves a trace, and vanishes before the next one arrives, there may never be overlap. The light never meets the light, and so the silence remains. But even in silence, there is beauty, there is dignity, there is wonder. Because the very fact that we can ask these questions, that we exist here now able to wonder, is extraordinary. We are a part of this universe, a brief, bright moment. One more eye-opening in the long sleep of the stars, and whether or not anyone else is out there, whether or not anyone came before, we're here, we're listening, we're reaching softly across the dark. Now we return our gaze gently homeward, toward Earth's farthest corners, to places where silence is not emptiness, but preservation. The icy ends of our world, Antarctica, Greenland, the frozen moons beyond. If anything on Earth could keep a secret for millions of years, it might be the ice. Ice doesn't decay like forests. It doesn't churn like oceans. It doesn't grind like tectonic plates. Instead, it accumulates, layer by layer, snowfall by snowfall, pressing memory into crystal. Mainstream science uses these frozen archives to read the past. Core samples taken from Antarctica, for example, can reach over 3 kilometers deep, preserving bubbles of ancient air. These pockets are tiny time machines. They let us measure the atmosphere as it was hundreds of thousands of years ago. We've used them to track carbon dioxide, methane, and even volcanic ash. From this, we've built our understanding of Earth's shifting climate and the rhythms of ice ages. But what else might be trapped down there? A lesser-known detail. Buried beneath kilometers of Antarctic ice are entire hidden landscapes. Mountains, lakes, even ancient river systems. One such lake, called Lake Vostok, lies sealed beneath over 4,000 meters of ice. It has been isolated for perhaps 15 million years. What lives there now, if anything, remains uncertain. What may have lived there before is even harder to guess. Some researchers propose that these subglacial worlds might preserve biosignatures, or even microbial life adapted to darkness and pressure. Others wonder if they could hold clues to past surface environments, or even unexpected traces of something stranger. Now consider this. If a civilization, or even a culture, existed long before the last ice ages, its remains might have been slowly buried by advancing glaciers. Not destroyed, just hidden, locked away in silence. We've barely begun to look. The challenges of drilling through such depths without contamination are immense, but as our tools improve, we're beginning to reach those depths, and each layer brings us closer to the deep past. The same possibility exists in Greenland, where the ice tells a different but equally ancient story. Even more tantalizing is the suggestion that beneath the ice may lie not just organic materials, but entire landforms untouched for millions of years. In these frozen regions, erosion halts, decay slows, and time thickens. Now let's drift even farther, to the outer solar system, to Europa, moon of Jupiter, to Enceladus, moon of Saturn. Both are wrapped in ice, but beneath that surface lies liquid water, heated by tidal forces from their parent planets. Geysers erupt from Enceladus' surface, spraying water vapour and organic molecules into space. Europa, too, shows signs of a vast subsurface ocean. NASA and ESA are preparing missions to explore these worlds, to sample the plumes, to scan the crust, to listen for motion beneath the freeze. What's less commonly discussed is this: if life, or even intelligence, had emerged beneath those alien oceans, it might never have reached the surface. Entire ecosystems could thrive in darkness, warmed by hydrothermal vents, completely unaware of the stars above. But even so, they might build, adapt, evolve. They might develop patterns of thought, of structure, of memory. And if that's possible there, why not here? Could Earth have once had icy refuges where life endured long past surface extinction? Could intelligence have hidden in cold places outlasting catastrophe? Or, more provocatively, could the ice itself have buried the traces of something that came before? This is not to suggest cities entombed in glaciers or machines frozen in the snow, but subtler things. A pattern in isotopes, a shaped structure where there should be none. An anomaly in the layering of time. The more we learn about ice, the more we realise its power, not just to preserve, but to pause the erosion of time. That's what makes it so precious. So patient, it waits. And in that waiting, it holds the possibility that the Earth has forgotten less than we thought. Perhaps deep beneath the poles something still rests, untouched, unweathered, unseen. Not proof, not even evidence. Just a door, very slightly open. A question, not quite answered. A hush, so we listen. To the creak of glaciers, to the pulse of trapped air, to the silence beneath the ice. Because in those quietest corners, the Earth may yet be remembering something we haven't even thought to ask. Across the quiet lands and icy depths we've explored, there is one force that reminds us of Earth's vulnerability to the cosmos: impact. Every so often, a visitor arrives from beyond, an asteroid, a comet, travelling fast, ancient, and silent. And when it strikes, it leaves a scar. Some of these scars are still visible, vast circular basins ringed with uplifted rock. Others have been weathered away, buried or forgotten, but the planet remembers, just barely. Mainstream science confirms dozens of impact craters across Earth, ranging in size from small pockmarks to structures hundreds of kilometers across. The most famous is Chicxulub, in the Yucatan Peninsula, widely believed to have caused the extinction of the non-avian dinosaurs around 66 million years ago. But Chicxulub is just one. There are others, older, fainter, and perhaps even some still undiscovered, hidden beneath oceans or forests, or warped by tectonics into near invisibility. What's lesser known is what sometimes remains from such impacts: tektites. Tektites are small glassy objects formed when a meteorite strikes with such heat and force that the surrounding ground is vaporized, melts, and then rains back down as molten droplets. They cool mid-air into strange, smooth shapes, black, green, or translucent, depending on their composition. Tektites can travel thousands of kilometers from the site of impact. They have been found in strewn fields across Southeast Asia, North America, and Australia. They are time capsules, tiny, accidental artifacts of planetary trauma, and perhaps of response. Here is where our wondering sharpens. What happens when a civilization is struck by such an event? On Earth, we've only had to imagine this in the abstract. But if intelligence arose before us, and lived during one of these massive impacts, what would have remained? Would their structure survive the blast? Would their artifacts be reduced to dust, vaporized like the rock around them? Or might some materials, glass, ceramics, synthetic compounds, survive as tektites? It's possible, though no known tektites bear signs of anything artificial. Still, scientists have proposed looking closer. Even just one inclusion, a fragment, a trace of something shaped, could change our understanding of the past. There's also the question of what impact events might bury. Some craters are so large that the explosion forms a basin, which is then slowly filled in with sediment. Over millions of years, the crater becomes invisible from the surface, but beneath that layer, preservation. Some of the best-kept fossils in Earth's history have been found in post-impact sediments, like those near the Tanis site in North Dakota, where fish, plants, and even glass spherules were frozen in the moment after the Chicxulub strike. So we imagine, if a culture existed before such an event, sophisticated or simple, visible or subtle, might it have left something behind, now buried beneath that sudden silence? Not cities, perhaps, but shadows. A concentration of strange isotopes, a seam of rare materials, a structure caught in the fossilizing sediment just before the wave. This isn't about conspiracy or secret history. It's about how fragile memory is on a planetary scale, because for Earth, a reset button does exist, and sometimes it falls from the sky. There's also a pattern to consider. Some scientists believe that mass extinctions, and by extension, great disruptions to life and possibly intelligence, occur on a rhythm, linked perhaps to the solar system's movement through the galaxy, passing through dense clouds, dislodging comets from the distant Oort cloud, sending them inward. If true, this galactic rhythm may act like a quiet clock, not one that ticks, but one that clears, not often, but enough. Enough to interrupt, enough to erase. And perhaps enough to explain the gaps we see in the record. Civilizations might not end in collapse or decay alone. Some might end with a light in the sky, a tremble in the crust, and then silence. And yet, even in that silence, small clues remain. Tektites, layered iridium, shocked quartz, the quiet mineral languages of catastrophe. In those layers, we read what happened, but not always who it happened to, and so the wondering continues. We're not just asking whether we're alone in the stars, we're asking whether we've been alone here, whether something rose before, lived its brief arc, and was swept away by fire, by stone, by time. Tektites are not fossils, they are flashes, moments when the world changed in an instant. And if any memory survived those flashes, it would be fragile, barely there, waiting in a riverbed, in a quarry, in a canyon wall, a droplet of glass with a story sealed inside. So we look, not just down, but inward. Because sometimes, to find what's forgotten, we must first remember how to listen. There is a different kind of memory the universe keeps. Not written in stone or buried in soil, not fossilized or frozen, but woven into the very fabric of space, a kind of cosmic whisper, gravity. We often think of gravity as just a force, the thing that holds us to the ground, that curves the paths of planets. But it is also a medium for memory, a way that large ancient movements leave impressions on the structure of the universe. Mainstream physics teaches us that gravitational waves ripple through space-time when massive bodies move violently, when black holes collide, or when neutron stars spiral into one another. These waves stretch and squeeze the fabric of reality itself. They pass through everything, unnoticed by all but the most sensitive instruments. The first direct detection of such a wave happened only recently, in 2015, by the LIGO Observatory. It was a moment of immense quiet significance. A new sense awakened, and with it came a lesser-known idea, that the universe itself may be recording the memory of its own events, through waves, warps, and curves. What if, long ago, a massive structure, a megastructure even, disturbed gravity in ways we have yet to fully understand? Not something as dramatic as a Dyson sphere or a starlifting engine, but even a modest artificial satellite, if large enough, would leave gravitational effects. Over time, those effects might fade, but some could remain. Echoes in the curves, anomalies in orbit, a motion that doesn't quite fit the models. This is the heart of gravitational archaeology, a young but growing field. Researchers are beginning to ask, could we detect past events not through light, but through geometry? Could the shape of a planet's motion hint at something hidden? Could the tilt of a moon's orbit suggest ancient influence? It's speculative, but not unscientific. We already know that mass can affect space-time. And we're beginning to learn how to read those distortions, not just for what's happening now, but for what happened long ago. If an intelligent species ever manipulated large-scale structures, orbital mirrors, rings, space elevators, their presence would have left tiny shifts in momentum, changes in balance, and unlike metal or stone, gravity does not decay. It ripples outward, across time. What's lesser known is that some gravitational anomalies already exist in our solar system. The orbits of certain trans-Neptunian objects don't behave quite as expected. Their paths hint at a massive, unseen influence, what some call Planet 9. Is it a planet, a cluster of dark matter, or something else? We don't yet know, but it shows us how little we've mapped the outer reaches of our own neighbourhood. If a civilization had once shaped or used these distant regions, the evidence might not be a ruin, but a resonance. And it's not just planets. Space itself can carry memory. The cosmic microwave background, the afterglow of the Big Bang, is a map of the universe's earliest fluctuations, but some theorists propose that even now, in the distribution of galaxies, in the quiet flows of dark matter, there might be patterns. Not deliberate ones, but ones left by motion, by thought, by effort. It's like watching a pond ripple and asking, what caused the wave? In this view, the universe becomes a canvas not just for physics, but for legacy. Of course, these ideas are young. They float on the edge of what we can test, but they offer something precious, a new kind of listening. Because if civilizations come and go, here or elsewhere, then perhaps light and stone aren't the only ways they speak. Perhaps they also speak through gravity, through the shape of motion, through the quiet bending of time itself. There's a humility in that. To think that our greatest efforts, our satellites, our ships, our stations, might someday be gone, but the gravity they once disturbed could linger, unseen, but still there, a whisper in orbit, a curve in the map, a trace in the dance of moons. It's not a monument, not a message, but it's real, and perhaps, one day, readable. So we continue listening, not just with telescopes and cameras, but with instruments that feel the stretching of space, that sense the invisible hands moving through the dark, because the universe remembers more than we think. And not all memories are written in dust. Some are woven into the shape of everything. Before there were reptiles, before there were fish, before even the simplest plants set down roots, there was life. Simple, strange, silent life. We now drift gently into Earth's deepest past, the Precambrian, a span of time so vast it makes all recorded history feel like a breath. Mainstream geology tells us this era makes up nearly 90% of Earth's timeline, and yet we know so little of what it held. It begins with the Earth's formation, 4.5 billion years ago, and it stretches forward past the cooling crust, the rise of oceans, and the birth of the first cells, all the way to about 540 million years ago, when the Cambrian explosion brought forth the ancestors of most modern animals. In between lies almost 4 billion years of mystery. 4 billion years of water, rock, heat, and possibly life. The first confirmed fossils are microbial mats, stromatolites, dating back over 3.5 billion years. They're still alive today in shallow salty pools, layering themselves up over time, like quiet biological pages. But what about the rest? The creatures with soft bodies? The strange chemistries? The things that didn't fossilize? A lesser-known fact, Precambrian fossils are extraordinarily rare, and even when they appear, they're often just impressions, shadows in stone without bone or shell. Because the organisms that lived in this time had no hard parts, no skeletons, no armour, no coral homes. They were soft, delicate, and easily erased. Yet for billions of years they ruled the world, and if anything more complex emerged, something we would recognise as aware, intentional, intelligent, how would we know? We wouldn't, not easily. Because no city could last that long. No artifact, no tower, no tablet could survive 3 billion years of weathering, erosion and subduction. Even the land itself changes. Most of Earth's surface rocks are younger than 2.5 billion years. The oldest crust is rare, isolated and deeply buried. This is where the idea of a ghost civilization feels most poignant. Not in the sense of spirits, but in the sense of something faint, something that once was, and now isn't. There is an old hypothesis, not widely accepted but still quietly considered. Could an early, now vanished branch of life, perhaps even intelligent, have evolved during the Precambrian? Not like us, maybe not even multicellular, but adapted to a different atmosphere, a different chemistry, a different kind of light. Back then, the atmosphere lacked oxygen for a long time. Early life may have used other elements, sulfur, methane, even iron, as energy sources, and the biosphere would have looked nothing like today's. Some believe that intelligence must arise from competition, from environmental pressure, but others suggest that complexity is an emergent property, that given enough time, organisation appears. 4 billion years is enough time, perhaps even too much. What if something did arise slowly, organically in those ancient seas? And what if it lasted just long enough to sense the world, alter its chemistry, leave a mark, and then dissolve again? Not with a bang, not with a collapse, just with change. Earth's atmosphere changed dramatically with the rise of photosynthesis. Oxygen appeared, and many anaerobic organisms, perhaps dominant at the time, were wiped out. It was a planetary reset, and perhaps a forgotten one. There is evidence of this in what scientists call the Great Oxidation Event, around 2.4 billion years ago. The entire chemistry of Earth shifted, and with it, entire lineages of life may have ended. We don't know what was lost. We only see the results. A different sky, a new era. But what if something was there, before that sky turned blue? Would we call it a civilization? Perhaps not, but perhaps it organised, built, communicated, adapted, and perhaps softly, briefly it dreamed. This is the beauty and the melancholy of deep time. It holds more than we can ever know. It erases not with malice, but with movement, and it leaves behind not stories, but silence. Still, the rocks whisper, in isotopic anomalies, in unexplained carbon patterns, in traces that don't quite fit the models. These are not answers, but they are questions, and tonight we rest inside those questions, not to solve them, but to hold them with care, because the Earth has had many chapters. And perhaps some of them are simply beyond recall, but not beyond reverence. To look at a quiet stone and wonder what it once held, that is its own kind of remembering. Even if the name is gone, even if the story is lost, we still listen, we still ask, and sometimes that's enough. There is an idea floating quietly at the edge of our search for life that asks us to shift our role, not from observer to explorer, not from questioner to answerer, but from centre to subject. It's called the zoo hypothesis, a soft, unsettling possibility. What if the reason we haven't heard from other civilizations is because they're watching? Like animals in a preserve, we might be under quiet observation, not interfered with, not contacted, just left to grow, or left to forget. The hypothesis is speculative, of course, not part of mainstream science in a formal way, but rather an exercise in humility. It forces us to ask, what if we're not alone? But we're not ready. Now tonight, let's turn that idea gently inside out. Not, what if they're watching us? But rather, what if we were once the watchers? In all the earlier sections, we've wondered whether other civilizations once existed here on Earth. Before us, beneath us, now vanished. But what if those ancient civilizations didn't vanish completely? What if they left, not by fading, but by choice? The notion is simple. Intelligence, once it emerges, might not stay planetary. It might look upward, and if it becomes advanced enough, technologically, philosophically, spiritually, it might leave its cradle entirely. We imagine this in science fiction. Ancient spacefarers, ascended species, post-biological minds drifting between stars. But perhaps, if Earth once hosted an intelligent species long ago, their path diverged. Not downward into collapse, but outward into silence. And perhaps they are still out there, still watching, not in ships, not in probes, but in patterns, in algorithms, in gently curved orbits. This isn't to say we're being controlled or manipulated. The zoo hypothesis isn't about power, it's about non-interference. Much like we might choose not to interrupt a forest we're studying, letting it grow, observing from a distance, so too might a mature intelligence choose to observe us without stepping in. Or perhaps, more humbly still, we were once that intelligence. We once watched, we once recorded, and then we stopped. Because civilizations, like species, may come to endings, not always with fire, sometimes with understanding. Maybe the Watchers didn't vanish. Maybe they chose silence, to leave no trace, to leave the Earth to its own rhythms, to allow new intelligences to arise without legacy weighing them down. This is, of course, speculative. A thought experiment. But even within mainstream astrobiology, there is a growing interest in the Anthropocene signature, the idea that a civilization might alter its planet's atmosphere, geology, or biosphere in ways that future observers or alien ones could detect. And some scientists wonder, could such signatures already exist here? In deep layers, in the carbon isotope record, in unexplained methane bursts, in patterns we haven't yet learned how to read. A lesser-known idea tied to the zoo hypothesis is the Sentinel hypothesis. It suggests that a civilization might plant quiet monitoring tools, beacons, sensors on habitable planets. Devices meant not to interfere, but to observe, passively, listening for signs of emergence, waiting for a spark, not to guide, not to judge, just to know. If such a sentinel existed, on Earth or in orbit, how would we find it? Would we even know what to look for? We often assume technology will resemble ours, metal, electricity, emissions, but perhaps a sentinel is mineral-based, or biological, or hidden in plain sight, masquerading as part of the landscape. Again, no evidence, just the thought, and this thought folds back into our original wondering. What if we're not the first? What if we are a second act, rising quietly after a first one chose to leave no mark? Wouldn't that explain the silence? Not because no one was here, but because they chose to depart gently, leaving behind a planet in balance, a stage cleared for what comes next, us. Perhaps we are not the lost children of Earth. Perhaps we are its second bloom, its second voice, and perhaps the first is still out there, still listening. Not gods, not aliens, just ancestors. So when we look to the stars and hear nothing, maybe that is by design. Maybe the silence is the point, a gift, an invitation to grow without pressure, to rise in our own way. Until one day we too choose to reach out, to stay quiet, or to become the watchers ourselves. And when that moment comes, if it ever does, we may understand the silence for what it truly is. Not loneliness, not abandonment, but respect. As we near the end of this quiet journey, we return to a gentle, humbling idea. What if we are not a beginning, but an echo? All this time, we've asked whether ancient civilizations might have come before us, whether they left traces, whether we could find them. But tonight, a softer possibility emerges. What if we are them? Not in memory, not in culture, not in bones, but in rhythm, in the way tides return, in the way stars form and fade, in the way certain patterns recur. Mainstream science recognizes cycles in nature, seasons, climate, orbital shifts. Species rise and fall with these long arcs. Mass extinctions come and go like planetary exhalations. There is a lesser-known rhythm too, called the Maya cycle in archaeology, an understanding among ancient cultures that time is not linear but circular. In this view, history does not move from start to finish, but turns like a wheel. What has been, may be again. In physics, there's something similar. Recurrence. Given enough time, systems return to earlier states. This is the Poincaré recurrence theorem, a concept that says, in a closed system, particles may eventually return to previous configurations no matter how complex. Perhaps civilizations are not exceptions to this. Perhaps intelligence arises, vanishes, and then returns, on different scales, in different forms, across different eras. Like a melody, the universe plays again, slightly altered each time. If so, then we, modern humans, may not be the first intelligent beings on this planet, nor the last. We may be part of a longer breath, a deeper inhale, a recurring note. There is something profoundly peaceful in that. Not fatalistic, not frightening, just cyclical. We often think of ourselves as standing at the pinnacle, the latest, the greatest, the most advanced. But maybe we're just a ripple, rising briefly before dissolving again. And maybe that's okay. It doesn't diminish our meaning, it expands it. Because if we are the echo of something long forgotten, we're also the beginning of whatever comes next. Echoes don't just repeat, they carry, they shape the room, they add to the sound. So even if there was something before us, something we can't remember, we are still part of that song. There are stories within geology of things returning, species thought extinct, reappearing in hidden valleys, plants vanishing from the record, then blooming again in fossil beds millions of years apart. These are called Lazarus taxa, and perhaps civilizations too have Lazarus moments. Moments when a spark returns to the world without fanfare or memory, only presence. That spark might be fire or language, or the building of a shelter, the telling of a story, the shaping of a tool. Moments so small and yet so ancient. Because even if we are new, our actions are not. They echo things done long before, and perhaps long after. We wonder about consciousness, whether it is rare or inevitable, whether the universe tends toward it, or whether it's just an accident flickering and fading in random places. But the longer we listen, the more it seems that intelligence once kindled may not be a flame that burns once. It may be a tide, coming and going, leaving shells on the shore, not all the same, not all remembered, but still part of the same ocean. So, if we are an echo, then perhaps we owe our existence not to randomness, but to rhythm, not to uniqueness, but to continuity. And if that's true, then we walk not alone, but with ghosts, not in fear, but in reverence. Because somewhere far beneath us, or far before us, or far beyond us, someone may have wondered just as we do now. They too may have looked at the stars. They too may have asked what came before. They too may have listened for echoes. And now, perhaps we are the ones answering, not with certainty, but with wonder, not with monuments, but with care. So we carry the echo forward. We build not just for now, but for some future we may never see. We speak, knowing our words might fade. We love, knowing time is long, and in that we become something ancient. If everything moves in cycles, stars, seasons, civilizations, then perhaps the rise and fall of intelligence is not a story with a single ending, but a pattern with many variations, a rhythm that the universe plays in soft, slow time. So tonight, as we come to the final quiet stretch of this journey, we let the idea settle like dust on a forgotten shelf. Civilizations like forests may come and go. They bloom, they burn, they scatter seeds in silence, and sometimes they return. We are used to thinking of civilization as linear, progress as a straight path upward, but the earth does not grow in lines, it grows in spirals, in rings, in returns. Mainstream science acknowledges this in the fossil record. It shows long periods of stability, then sudden transitions, mass extinctions, reinventions, explosions of form and diversity. And after each one, life finds a way back. A lesser-known pattern is that of faunal turnover. Whole ecological communities disappear, and others rise to take their place, often in unfamiliar combinations. Not copies, not reboots, but entirely new experiments on the same stage. Could civilizations behave the same way? Not the same culture, not the same species, not even the same tools, but the same underlying gesture to build, to remember. To look upward, to leave a trace. Perhaps there have been many such gestures on Earth, and perhaps they are not failures when they fade. Perhaps they are seasons, some spring, some fall, some long and slow, others brief and bright. We see this mirrored in the stars. Stars too are born, they burn, they collapse, and in their deaths they scatter the elements needed for the next generation. Carbon, oxygen, iron, gold, everything we are made of. So if stars cycle, and forests cycle, and life cycles, why not civilization? It's possible that the Earth has had many intelligences, not just one species or one timeline, but many awakenings, each forgotten by the next, each contributing in silence to the future. Even now we may be leaving behind something subtle that will shape what comes after us, not in ruins or machines, but in soil, in air, in story. This is the gentlest way to think about deep time, not as a record of loss, but as a garden of returns. And it changes how we carry ourselves. If we're not the first, if we're not the only, then we are part of something larger, not separate from the cosmos, but a moment within it, a note in a symphony, a ring in the tree, a ripple in the dark, and that's enough. We don't need to be remembered forever. We don't need to be the beginning or the end. We only need to be here, to wonder, to reach, to leave behind something kind, something thoughtful for whatever might come next, not because it will last, but because it will echo, and perhaps someday someone else will wonder, not who we were or what we built, but whether they too are part of the rhythm, whether they are one more season in a planet that blooms intelligence again and again, each time different, each time meaningful. So we fade now, not into nothing, but into quiet continuity. The earth turns, the stars drift, the cycle continues, and in its turning, maybe, just maybe, it remembers us. Now, as the stars continue their slow arcs across the velvet sky, and our thoughts settle back into stillness, we let the final echoes of this journey dissolve. We have wandered through deep time, through ancient layers and lost horizons. We've floated across deserts and oceans, dust and ice, light and gravity. We've listened to the possibility that Earth's story may be longer, richer, and more layered than we've ever known. And in that listening, we've made space, not for certainty, but for calm wonder. Perhaps we are not the first. Perhaps we are an echo. Perhaps we are a rhythm playing itself out again in a new key. The moon still watches, the ice still keeps its breath, the rocks still whisper of ancient fire and water, and somewhere, far above or far below, silence holds stories no voice has spoken for a very long time. You don't need to remember it all. You don't need to solve the mystery. Just carry the quiet. Let it move with your breath, as steady as the earth's slow turning. With each inhale, imagine the ancient air that has passed through forests long vanished. With each exhale, imagine it becoming part of the future, a gift, a trace, a kindness. The stars above us are old, but they still shine, and so do we, in our own soft way. You've been listening to Sleepy Cosmic Podcast. Thank you for drifting with us. Sleep well now. You are part of something vast, and tonight that is more than enough.